Thank you all for joining. And let's go ahead and get started. All right. With that, I'm glad everyone has joined geometry today. So today we're teaching triangles, circles, and trigonometry. This is going to be available on your SAT when you take a practice online exam. You should definitely play around with just, even if you can't finish the exam, that's fine. On Testive and the Blue Book on by College Board, just play around with like being comfortable with Desmos, being comfortable with checking reference sheets. Even if it means you like waste 10 minutes, that's fine because you just want to be able to use it quickly when the exam comes. I'm not, I mean, I'll probably flip back to it during today's lesson, but if you can just take a screenshot, then that would be much easier for when we do the practice problems. Um, okay, so some things to remember. Um, I like the bottom a lot. The number of degrees in an arc in a circle is 360 degrees. That's good because that comes up a ton with radians. The number of radians of an arc in a circle is 2 pi. And then the sum of measures in degrees of the angles of a triangle is 180 degrees. So in case you forget, it's there for you and you don't have to force yourself to remember. Okay, so we're gonna do total degrees in a triangle is 180 degrees. Supplementary versus complementary angles. So that would be in a line. A line is also 180 degrees. So if this is 50 degrees, this has to be 180 degrees minus 50 degrees, which equals 130 degrees, always in a line. Always the case. And if it's, why is it 180? It's because a circle is 360 degrees. And if you put a line right through it, this is 180 degrees, and this is 180 degrees. We also have similar triangles. So that could be something like this. And we're told this is parallel. It could be a right triangle. It could be any kind of normal angle triangle, but they might share an angle. And that means that this angle, those two are equal because of the parallel lines. Okay, and then these are also equal angles because of the parallel lines. And so what that means is that the length of this piece, oh, the length of that piece is the length of the x over y would be equivalent to the length of, let's call this a over b, because they share angles and because they're proportionate. Isosceles triangles have two equal sides, not so. When you have two equal sides, that means these angles are also equal. If this is 5 and this is 5, then they share the same angle measurement as well. And we'll see that in practice today. Okay, we'll get started. I'm going to go ahead and solve problems for the next 20 minutes or so, just a review of what we've taught in class. And then at the end, we have 6 problems that I'm going to let you guys try for 2-3 minutes, and then I will work through the answer, just to give a roadmap for today. So we have, in the figure above, lines L and M are parallel. This is key information. Sorry, I get bigger. L and M are parallel. Y is 30 degrees and Z is 45 degrees. Because of these parallel lines, that means that this is also the measurement z. They're the same. So this is 45 degrees. So the equation to find x would be 180 degrees equals 30 plus 45 plus x. 30 plus 45 is 75. So we subtract 75 from both sides and we get 105 degrees equals x. Answer choice B. You can work along with me. You probably might be faster than me. But this is the solution if anyone has any questions. Okay, no questions. Let's move on. For right triangle trigonometry, these 6 triangles are super duper important. The good thing is they give it to you in the exam. So if you see, find the length of a missing side and you have 2 of the sides, you know a squared plus b squared equals c squared. And if you forget, it's not a problem because the SAT will give it to you if you practice properly with on Testive and in the blue book. Then we have this special right triangle, 30, 60, 90 triangle. Honestly, they're my least favorite of the special right triangles, but because of this root 3, but it's important to just recognize that if you see a root 3 or if you see a 30, 60 degrees, you need to just re-reference back to the reference sheet just so that you get the right side with the right angle, like the x is directly opposite the 30 degrees and the x root 3 is directly opposite the 60 degrees. And these also will show up in circles. Then we have the 45, 45 isosceles right triangle. This one I like a little bit more. And that's just because it's a little bit more simpler. The sides are s and s, and the hypotenuse is s root 2. Then we have SOHCAHTOA, or sine, cosine, and tangent. And when you're trying to find the measurement of this angle, and you're using sine, it's opposite over hypotenuse. If you're trying to find the cosine of this angle, it's adjacent over hypotenuse, which is here. Just write it. And then we have tan, which is opposite over adjacent. And if you forget, it's not a problem because the SAT will very nicely give it to you. You just need to be comfortable using it, which we will definitely go over today. Okay, so we have this question, triangle ABC is shown above. What is tan of ABC when it says that the middle letter is the angle in question? So it's this one, and that's really important to remember. And so tan is opposite over adjacent. I'm just going to label hypotenuse so we have it. So it's 5 over 6. It's answer choice A. Does anybody have questions on this one? All right, we're going to continue. Okay. In this right triangle shown, the length of AC is 5 and the length of AB is 6. They're very nicely labeled for us. What is the length of BC? We're going to use A squared plus B squared equals C squared. So this is A, this is B, and this is C. But you could also very well make this B and A. A and B are interchangeable, C is not. So we have A squared plus B squared equals C squared. Plug and chug. 5 squared plus B squared equals 6 squared. 25 plus B squared equals 36. B squared equals 11, minus 25 on both sides. I'll show it so we have it for the video. And then we're going to take the square root. So we get B equals the square root of 11. Just answer choice B. Anyone have questions on this question? All right. Going to go to the next one. Do circle theorems. It's a little bit funkier. and I think it can be a little bit harder to understand, especially when they have triangles in the circles, but not to worry. Um, just practice in testive. I'll assign more math problems so that everyone will have access. So something really important is whatever degree this angle is right here, if you divide it by 360, it can give you the same ratio of like the circumference of BC over the whole circle, or it can give you the area. So it can also give you this shaded area as a ratio over, the whole circle. Sorry, that was badly illustrated, but over the whole circle. And we're going to show it in practice today. So if you have a question or it's confusing, just please stop me. The two other really important equations in circles are A equals pi r squared, which is area, and circumference is 2 pi r. And the really, really, really nice thing here is that pi is the same. And so if you have the area, you can figure out the circumference, because let's say the area equals 36 pi, and the question asks you circumference, like what is circumference? Like that, then you can go, okay, well, pi r squared equals 36 pi. Take out the pi, r squared equals 36, r equals 6. Then if we need to find circumference, we know the equation is 2 pi r. So we plug and chuck. We do circumference equals 2 pi times 6 for r. We get circumference is 12 pi. So you can figure out you can figure out area if you have circumference, and you can figure out circumference if you have area. In much more complicated questions, you can also use this relation between area and circumference for sectors, which is important to remember and takes a little bit extra time, which is annoying. And so that's okay. All right. We're going to do this example. In the figure O is the center right here of the circle, and AC is the diameter of the circle. If AC is the diameter of the circle, this is the radius, this is the radius, this is the radius. And it's asking us to figure out the value of X. And so something we know is that we have an isosceles triangle, that this 25 degrees here is the same here, only because it's isosceles, and it's isosceles because we have they're both lengths are the radius. If that's 25 and this is 25, then this, let's call this y, 180 equals y plus 25 plus 25, 180 equals y plus 50, 130 degrees equals y, okay? And x, 180 equals x plus y, right? The full line. And so 180 equals x plus 130. So x equals 50 degrees. That's how I would solve it. But if you're really comfortable with the circle and you remember this, inscribed angles, it's like a special math rule, are 1/2 the central angle. And it's just kind of a weird rule. So what's really nice is if you know that, then if this is 25, and then this basically has to be 50 because it's 2 times the inscribed angle, because it's the central angle. I find that a little bit harder, and so I prefer using the isosceles triangle. Okay, so the example slide. We'll stay on this slide for a little bit. Any background noise you hear, it's because I'm in India right now, and so there's just Hindi being spoken in the hallway. Um, all right, I'm gonna go to the next one. Okay, so now we have this figure, point O is the center again, and the shaded area is 3/8 the area of the circle. So what is the value of X? So for this one, we have to do, oh, sorry. Oh, X, okay. So 3/8 is the ratio of the shaded area over the full circle. And we know that they are very beautifully related. And so it's the same ratio of X degrees over 360 degrees. And so when we cross multiply and to solve for X, we get 3 times 360 equals 8 times X degrees. We can just drop the degrees, it's not important. Times X, since it's there. And then we have, I'm just doing the circle, 3 times 360 divided by 8 equals X. If you solve that out, pretty sure it's 135. I'm just going to check it really quick in the calculator. And it is 135 degrees. A little bit more straightforward. Anybody have questions on this? Okay. Now we have unit circle trigonometry. And I think this is a little bit irritating and annoying. But from that first slide, it says a full circle is 2 pi radians. And it also says that a full circle is 360 degrees. So I think it's just really nice to do 360 degrees equals 2 pi. Or right here, 180 degrees equals pi. We have this thing where radian measure over pi is equal to the degree measure over 180. It can also just be a little bit easy to remember that in a circle like this is pi over 6, this is pi over 4, and this is pi over 3. And that also correlates to, I'm gonna do it in red, 30 degrees, 45 degrees, 60 degrees. And it kind of measures over the same to the other side, that, and it just mirrors, and you just add a whole one. So this is, yeah, you'll see, it gets a little funky. So for this question, which of the following radian measures equals to 135 degrees? And so we can do 100 over 180 degrees equals X over pi. And then we cross multiply. 135 pi all over 180 pi, sorry, just 1 pi, equals X. And we can see on the side, no real point dividing because the answer is with pi and radians. And so if you wanted to simplify it in your graphing calculator, it would come out to 3 pi over 4 equals X. And so the answer choice is C. The other way of doing it is, if you remember in the previous slide, pi over 4 equals 45 degrees. And so 135 divided by 45 actually gives you 3. Let me do it another way. That's nicer. Okay. And so that could be, it's 3 times pi over 4 radians. Either way would work. Anyone have questions? I know radians are kind of hard. All right. Circle equation, trigonometry. So we have x minus h all squared plus y minus k all squared equals r squared. H comma k is O, or the center of the circle. And radians, or sorry, not radians, the radius is here. And so we squared for the equation. So just remember this because it'll be important for all circle of equation questions. And the big thing they're going to test you on is, do you remember that the radius is squared in the equation? And do you remember that it's x minus h squared, not x plus h squared plus y plus. That's a really common mistake. And so they will almost always test it in the answer choices. So just do your best to remember that. And you should be all okay. Here's the question. So we have xy plane with the center -3, -4. Good to know. And the radius is 5. Our equation is x minus h squared plus y minus k squared equals r squared. Easier right now because we had it on the previous page. We're going to plug x minus -3 squared plus y minus -4 squared equals 5 squared. Minus minus is x plus 3 all squared plus y plus 4 all squared equals 25. And so if we look over the answer choices, they do exactly what I warned you. They're going to hope that you forget that rule here and you forget that the radius is squared, not that. This one, you got the minus minus sign, so it's positive, correct, but the radius is wrong, so that's not it. Here again, they're hoping that you mess up the equation on this point, but they got the radius correct, and the answer choice is D, which is what we got here. If you're really comfortable with circle of equation and you just know this really well, then you can actually just take this and jump right to D. But I would prefer if you just took the extra 10 seconds, 15 seconds to write it down in Chicken Scratch on your paper, just so that when you go back to the answer choices with the testing environment, that you can just make sure you got the right one. Because I can see a really easy, silly mistake happening here that really shouldn't. We want the free points just from being on top of our negatives and positives and easy squarings. Okay. We have completing the square, and we basically have to rearrange the equation by moving constants to one side. And so basically, like if we have an equation where we're supposed to add enough to get the constants, to get it in the circle of equation form, we sometimes have to, like, if we see x squared minus 6x equals 16, and we want to make it like a circle equation, or we just need to complete the square, then we know that x squared minus 6x is probably x minus 3 squared, but in x minus 3 squared, when you bring it out, it's x squared minus 6x plus 9. So what you would do is, knowing that, you would add 9 to both sides to make it 25. So x minus 3 squared equals 5 squared, or 25, either way. So this is a little bit important, and it's gonna be important for our next few questions. And then factoring and solving is also part of it. So we have this equation, and it's x squared plus 6x. I'm gonna just do the next part in y. plus y squared minus 4y, let's just do equals 3. We're gonna make the colors to make it really easy. To do this, x squared plus 6x, we know plus 9. So I'm gonna add plus 9. And then we also know that y squared minus 4y, we want to do y minus 2 all squared. Negative 2 times negative 2 is positive 4. So I'm going to add 4. And so on this side, we should do the same on both sides. Plus 9 plus 4. So we have x plus 6x, 9, x squared plus 6x plus 9, plus y squared minus 4y plus 4 equals 3 plus 9 is 12. 12 plus 4 is 16, equals 16. And so just keeping the colors. Okay, so now that we've completed the square, I like to think elegantly with all the different colors. We have x plus 3 all squared plus y minus 2 all squared equals 4 squared. And so what we know from this is the circle equation is okay, so we know that this is the equation. And so the center of the circle, the coordinates are -3, 2. And just to go a step further, we also know that the radius is 4. And so this is how we would use completing the square to figure out what the coordinates are and what the radius is. And so the answer choice is B. If you are super duper extremely comfortable with circle of equation, and you know right here that you're solving for x plus 3 squared, right here, okay? And you know this is y minus 2 squared, and you can see that it's not asking for the radius, you can actually jump and just know it's -3, 2. But I think if you go too fast, you might end up picking this answer choice. So I would just say, just take the extra 30 seconds to just complete the square and make sure you're correct. Yeah. And then 6 and 4 are trick answer choices because those are the coefficients here, and they're just hoping that you might not know how to complete the square, and that's why you picked that. Okay, any questions? Yeah, so for circle questions or circle problems, you would use completing the square twice for both x and y. Maybe it's there for one of them. Like, for example, maybe the question was asking x squared plus 6x plus 9 plus y squared minus 4y equals 3. Sorry, let's just make it equals 12 since it's there. Then you just need to complete the square for just the y. So you may have to use it twice. You can use it just once. And yeah, so for username Barnabas, yes, the 9 comes from 3 times 3 because it's x plus 3 squared. So if you actually, and it just comes from, unfortunately, quickly knowing it. So when you see 6x, you just know 3 and 3. It's a square. And even here, 4 is because -2, -2, -2. So you just take this center number and divide it by 2, multiplied by itself to get the coefficients that you add. Or I think the coefficient is not the coefficient, the integer or that you would add. All right, we're gonna do some practice problems. I'm gonna give 2 minutes for each one. Please answer or punch your answer choices into the chat, and then I'm gonna explain each one. All right, just gonna go ahead and solve it. So we have square x that has sides that are 12, and we have square y, it's a little bit bigger, and the perimeter of y is 2 times the perimeter of x. So y equals 2x on perimeter. And we know that the perimeter of x is 12 times 4, or 12 plus 12 plus 12 plus 12, which is 48. And so y equals 2 times 48. So y equals 96. Except we need to know the side in centimeters of one length of y. And so we just do 96 divided by 4, which equals 24. It is answer choice D. And if you're really comfortable with like perimeters and areas of squares, and honestly circles, another trick I'm just going to show right now that we saw from this is that, it's 2 times the perimeter of, or the side of x. And so what we can do is we can just test it out. We can just say, let's say it's 5, 5, 5, 5, and our other square is 10, 10, 10, 10. This perimeter is 40 and this perimeter is 20. And so they're usually double. Area, it gets a little bit more complicated. So this area is 25 for the triangle. Let's call this triangle A, or not triangle, square A. And this is square B. This area is 100. And so these are 4 times each other, and that's because the lengths are 2 times, so it's squared. So they're usually related, and as you get more comfortable with geometry on the practice questions, you'll see certain trends, and it's good to kind of recognize them and just test if they're correct. Yeah, so the answer choice is 24. Good job. Let's try this one. All right, so I think it's nice to kind of quickly draw it out. So we have right triangles FGH is similar to right triangle JKL. And so what I like to do is something like this. And there's just a little bit of space here. And so let's say this is, and G and K are the right angles. So this is G and K. So let's say this is FGH. And this one, just keep it in red, that's fine. And this one is JKL. And it also tells us that angle F corresponds to angle J. And that's because they're similar triangles, so they're kind of the same. If sine of F equals 308 over 17, 317, then sine of J is the exact same ratio because it's the same degrees. So the answer choice is B. It's the same. And you could honestly get this from not even drawing it out. You could just see that it's telling you, we have these triangles and it's a right triangle and F is J. So the sign would be the same. But I'm very visual. And so I would take the extra minute or so to just kind of draw it out so I'm seeing it properly. Just because maybe it was a little bit more complicated and maybe you were supposed to find some missing side, or I don't know, but let's see if there's any questions. Okay, good job. I know this one's a little bit tougher, but if you just chicken scratch it out, you'll get it right away. Let's do this one. Okay, so we don't even need to draw this out, but if you want to draw it out, you totally could. We know that triangles have 180 degrees, and we have to find angle A plus B plus C. And if we just plug, let me get this. And then let's not do it that way. Let's just minus 52 degrees, minus 17 degrees, minus 52 degrees, minus 17 degrees. And if you do the math, you can totally use your calculator. A is 111 degrees, which gives us answer choice D. Let me see if there's any questions here. None. All right, we're gonna move on. Good job. Let's take a few minutes to do this one. Okay, this question's kind of funny. We have circle O. Sorry, a circle with center O. And we have R and S on the circle. This angle is 88 degrees. And so it asks us what's the measure of ROS in degrees, which would also be 88 degrees. So those of you who answer that, that's correct. Usually what they will normally ask, which I'm surprised they didn't ask here, is they're going to ask you, what is this? The other degree, RSO or SRO. And so to find that, we would, because this is the radius, we would do 180 equals 88 plus x, since they're the same and it's isosceles. 180 minus 88 is 92. And that's 2x, so x equals 46 degrees for those ones. But yeah, this question asks for ROS, which is the same as that. Okay, we will go to the next one. And this is going to take a little bit extra time. So why don't we take 3 minutes or so to do this problem since we're seeing it for the first time. Okay, this question's a little bit harder. So we're going to work on it. So we have an isosceles right triangle where this side and this side are the same. So let's call it X. And in an isosceles right triangle, a special right triangle, this is X root 2. Okay? And so it's asking, what is the length in inches of one leg of this triangle? The legs are X. So it's asking, what is X? And the equation for a perimeter is X plus X root 2. I'm gonna do it really nicely because it's gonna get real funky. So this equals 94 plus 94 root 2. Now, if you sit here and look at it, the roots make this frustrating. And so you can go ahead and solve. But what I found a lot easier is to just plug these numbers in for X kind of mentally and see what comes out. And so if it's, X and X, and let's make this, let's make this X and this X root 2, then the sum of that would be this. So if we go to A, it's 47, 47, 47 root 2. And a lot of people picked A. That does not, this is 94 plus 47 root 2, so it's not A. And if we go to B, it's 47 root 2 plus 47 root 2. And then it's 47 root 2 times root 2. Root 2 times root 2 is 2. And 2 times 47 is 94. Answer choice B, as gross as it looks, is 94 plus 94 root 2. And so it's actually answer choice B. Okay, it's answer choice B, but just for the sake of solving them all out, So someone asked, where does the x square root 2 come from? From here. So if we know the side of x in a special right triangle where it's 45 degrees, you would multiply that side by root 2. So whatever value we're getting for x, we're going to use the other one for the other leg, x. And then to find the perimeter, we're going to multiply x, whatever the value is, by root 2 to get the hypotenuse. And that's only in a special right triangle that's isosceles where these are 45 degrees. If we do answer choice C, we get x is also 94, and x root 2, which is the hypotenuse, is 94 root 2. That's too big. It's 94 root 2 plus, I think 198. No, 190. 100 and, sorry, 100, 188 is that side, is C. And then over here for D, we get 94 root 2 for XX. And then we do 94 root 2 times 2, which is 100. Just want to make sure I'm getting it right. 94 plus 94, 188. And so the perimeter is the sum of all three of these. Yeah, you would, so to solve for x algebraically, you would square both sides and then use FOIL. And I found that to take too much time, so I just liked the plug and chug method, but you can totally do that. And there's another question that says, wouldn't we do 94 divided by 2 to get x? No. We would do 94 divided by root 2 to get x. And that's also kind of hard to do, and you can use Desmos and figure it out, or your graphing calculator. But I found it much easier to just look at the special right triangle and to just kind of create a table and plug and play. And this was the way I could do it in under 90 seconds or a minute. And I think if you sit here trying to solve this equation, it would take more than 2 minutes, and it's probably prone to more mistakes. But whatever way you can get there is I'm okay with, because that's the best way to get there. You can try it on your own time and just make sure that you get answer choice B as your answer, and then you're good to go. I'm gonna go, this was a much harder question. And it's probably one that gets missed a lot more on the SAT. So, and they're just hoping that you're really comfortable with right triangles and really comfortable with x and x root 2. So if you're not, and this is confusing, it's a great place to spend your February break working on it. All right, let's do this one. And this is our last question. Okay, so the moment I saw the 199 divided by 2, I abandoned completing the square on my own and decided just to use Desmos and to graph the circle and to count the radius. So we get x squared plus x plus y squared equals 199 divided by 2. All right, that's the equation. And sorry, it's hard to see with zoom on my screen. All right. So this is the circle. The center is, you would have to complete the square to see it. But since the top is 10 and the bottom is 10 and this is negative 10 and a half, and this is yeah, 9.87. So what we could do is you could take the distance from the tip, or sorry, the top, which is 9.987, to the bottom, which is also 9.987. On the side, we have negative 10.5 and something. And we also have about that, oh, come on, right here. Ooh, it's kind of gross. Okay, it gets funky. And then we would find the center. And the best way is to actually just ignore the center and to just see the difference, 9.987 plus 9.987. Okay, and that's 19.74. And let's just do these sides, which is, oh, it's deciding not to give it to us. That's exciting. So we can actually just take 9.987 divided by 2, or what it adds up to, which is 19.974 divided by 2, and you get 9.987, and that's the radius. Sorry, it went away. That's how we get the length of the radius. Okay. Anyone have, let's see. If you said 10, you would get it wrong. Because it's 199 divided by 2. If it was 200, then 199 divided by 2 is yeah, if you said 10, you'd get it wrong. You would also have to change, and yeah, you would have to change the first half. You can't just square it right away. And this is a much harder question. So for things like this, which are hard to do algebraically, and if it's, circle equations and you can't figure out a solution, I would just go ahead and graph it in Desmos, and it saves a ton of time. So I'm going to go ahead and exit the call. Lily's going to take over. Hi, Lily.
Hi, how you doing?
Good. How are you?
I'm good. I hope everyone's excited for some words and context prep.
Yes, I'm going to hand over the reins and I'll take leave.
All right, fantastic.
Have fun.